Okay, so next, these are some of the terms we already, I mean, the book's already kind of talked a little bit about that in chapter 1. We will revisit this in chapter 10 because it does get a little bit complicated, but we won't do this until we get there. So, but again, throughout the book, you'll probably run into these terms again. So we do hear them, kind of know what they mean. Okay, but for now, don't worry about these yet. So classes, again, a Java program must have at least one class. Okay, you cannot have a class in Java, whereas other languages you don't have to have because you can use it as both an object or a procedural. Like for example, PHP, right? It's a web development program. You don't have to use it as an object, so therefore you don't have to have a class. Okay, but Java does. And there are three categories of classes in most object-oriented programming languages. Java actually has a lot more. They're very more specific, but in general, we have three types, and we have the concrete class. This means that the a class has everything in there. Everything is implemented. All the functions, methods are fully implemented. The word implemented means if you create a method, a function, then inside the function, all the codes are supplied. Okay, that means it's fully implemented. So when I ask you to, let's just say, if I have a function or definition, and this function is supposed to return the largest value of three numbers, then I said implement the function. That means you go ahead and supply the code. Okay, so a concrete class is a class that have everything is implemented, all the methods, and a concrete class is the only class that can create objects. Okay, you cannot create objects out of the other classes here, and we'll explain a little bit more later on. So that is a concrete class. So the classes you've been working so far with your main method and you do your assignments, those are all concrete classes because those are fully, there's no abstract methods in there. So the next class is the abstract class. Again, the term abstract means it's like kind of very generalized. Okay? It does not have everything implemented. It does have some functions. If I have, let's just say, 3 or 4 functions in there and they're implemented, at least one of them is not implemented. Okay, then it's an abstract class. When you have a method in there that is not implemented, then we call those classes abstract classes, and abstract classes cannot create objects. So you cannot say new student, okay, if it's an abstract class. Okay. And then we have the interface class. It's a special class. This is very, very general. It's more general than the abstract class. This class, you cannot implement any of the methods. You just have the definition of the function. Let's just say, function, public, int, calculate age, and then that's all you supply. You don't do the implementations. You can't even have any of the variable names in there, so no attributes either, just functions in there, and those functions are fully not implemented. So that's an interface. Again, this will be, these two here, we won't be doing that until later chapters, probably again around chapter 10, but I want just to let you know. So for now, we'll be dealing with just the concrete class, which is the first type, okay? So creating classes, this is how you create classes. I just kind of put the simple syntax here. So anything in brackets are optional. Maybe you don't have to put in there. Everything in blue will be required. Okay, so when you create a class, you have to write it this way. So an example here would be like a public class employee. Okay, and this is the access modifier, and it's optional. You don't have to put it there. Okay, but the book always puts it. It's by convention you always put it as a public, because if it's not public, then there's no way of creating an object out of that. You cannot call any private data. Okay, so usually it's all public by default. And then the extends here, again, we'll do that a little bit more. Maybe we'll see if I have time today. If not, maybe next time. Extends means you are creating a relationship between two classes, and these two classes belong maybe to the same, they have something in common. Okay, so for example, a company will be the parent class, and then the employee will be a child class of the company, because the company is more general, right? It's a real general class, and then under that you have employees. And then you have, maybe you can have you know, stakeholders or whatever other groups, other classes belong to a company. Okay, so we use the keyword extends, meaning to become the child class of a parent class. Okay, so the parent class is the one on the right. The child class is the one on the left. Okay. Okay, data fields. Again, back to this is the properties again. So data fields are, of course, just your usual variables. You've been using that for the last 2 chapters. Okay, so we can create a variable name, especially in chapter 2. That is a data field. The only difference is that data fields are created inside the class. Okay, inside the class and outside of any function. Okay, I did a little bit of that last week, but so data fields exist outside of functions. Okay, instance methods. Instance methods are methods that do not have the keyword static in front of them. Okay, so for example, the main method you've been seeing so far is not an instance method because it has the keyword static. Okay, instance methods, same thing with your data fields. Okay, for example, this is not an instance variable; it's a static variable. Whereas this one is an instance variable. It does not have the keyword static, and I'll show you what that means when we do some demos. Okay, so when you create a method, again, a method is a function. You will follow these rules here. Again, the modifiers, whether it's a static or not, go here, and then the data type, and then the name of the function, and any parameters you would pass those functions. Okay, again, those will be optional. And if this data type is not void, then you must use the return statement. You must return something back. Okay, so a function usually returns something back, but if you set it to say void as the data type, then this statement is not required. So if you see the static main method in your main program, you don't have to put a return statement in there. Okay, so that's the difference between a function and a procedure. Okay. Yeah, this is the examples here. I will do example on the class a little bit later. This is a function or method that is of type static, right? It returns no data, no value, and that's the main function. We see that all the time, all these times. This one here is a function or method that returns a data type of double. Okay, and it accepts 2 parameters. The first is an A. A is also type double, and then B is also type double. Okay, so a function can take arguments or no arguments. I'm sorry, this is an error here. This should be a parentheses. So for example, the main method takes 1 argument called args. Okay, and here you have another one. This is a special function. It's called calculate rank, and it returns a type of string, but it takes an object as a parameter, so employee object, and then it returns a string, so therefore I can return either valedictorian or a top 10 as a string back. And if using if block, right, so only one return statement can return back. You cannot have 2 or 3 or 4 or 5 and expect all of them to return data back. Only one of them will be executed, and once that's executed, then the rest of the code stops there. Okay, so if it runs this code, and if the first case is true, then it will return the word valedictorian, and then the rest of the code will be ignored from that point. So it will exit out of the function, and it's done. If this is not true, then it will go to the next case, and then if this is true, then it will execute this and return that as well. Okay. Actually, I should have another one because I have an else if here. So I should just say make it more correct, let's do this. Else, if none of those match, then I have to have the else part, and this is the catch-all. So return none or something. Okay, so this is a catch-all. So I have 3 return statements, but only one of those will be processed, executed, and then returns a string back to wherever it's been called. Okay? Yeah, you can do as many as you want, yes. So if it's true, else do this, else if, you can have a long chain of if blocks. We'll deal with that later on. These are conditional statements. Or you can use something called a switch statement. We'll get there in, I think, chapter 4, chapter 5. Okay? So mutators and accessor methods, these are also called setters and getters. So when you hear the term setters and getters, this is exactly what they are. Setters and getters are used to set and get data from the data fields. Okay, so every data field that you create in your class, you probably want to have a setter or a get and a getter with it. So you can set the data and also retrieve the data from those fields. So for example, here is a setter. It will set the employee number to this input value from somewhere. So it does not return anything because all it does is just setting or updating the data. It's not returning any data, so you set it to void. So the setter is always a void type. Okay. The getter, and again, by convention, you always see the word set, and then followed by the variable name, and the get followed by the variable name. So the variable name will be emp num, right? Lowercase, the first character. But in the setter and getter method, it's always all the camel casing. So set and get. I mean, you don't have to call it set and get. You can call it whatever you want. Doesn't matter. But by convention, it's always set something, get something. It's just easier to do to use it that way. So the getter, because you're going to get the data back and return it to someone who requests it, then it needs to set the data type. So if I'm returning this employee number, and I'm assuming this employee number is integer type, then it'll return integer type. If it's a string, then it will be string type. Okay? So setters and getters also called mutators for setting, because you're mutating the object or the variable data. So the state, the actual value of a instance variable is also called the state of that variable because it changes. Okay? So it mutates, so we call those mutators. Okay, so these are again a list of different types of static and non-static comparisons between the two. Again, you probably don't understand what this means yet, but it's easier when we start doing these examples in the code in the program. It's just a bit here. Okay, so and this list may not be complete, but it does cover a majority of the differences between the two. Okay. So when you create objects, you would, it takes 2 steps, usually 2 steps to do it. The first step is, if you look at this, it looks very similar to how you create in a variable name, right? Int num or string name, same idea, except you put the class name here instead of the int or the string or the Boolean type. Okay, so followed by the name of whatever the object is going to be, just a variable name. Okay, so when you do that, then the computer does not allocate any memory yet. It just says, oh, okay, there's a variable name called employee emp1, and it knows it's there, but it does not go into RAM and allocate that memory. Not until you reach step 2, when you issue the new keyword followed by the constructor. Then, and only then, memory is allocated in RAM, and then the object becomes active, becomes alive. Okay, so from that point on, then you can start using emp1 to access data or do some other stuff. Okay, so those 2 steps can be combined together to form a single step like this. And this is very common. It's probably the most common way You see this a lot in almost every object-oriented language, programming language you see. This is the way to go because I mean sooner or later you're going to allocate it anyway. So if you just to if you put I'm sorry if you put if you create this and if you're not going to use it, what for, right? So usually you'll use it right away and you can instantiate it right away. So this is called instantiation. The keyword new is always you instantiate or create an object. Okay? Okay, a little bit on constructor. So constructor is a special function method in a class, and it always applies to classes only. Okay, so every class must have at least one constructor. And a constructor, a class, this is kind of important here. I'll explain what this means by the unique signature because this is important later on when we talked about polymorphism. Okay, that means that each method, both including the constructor and your regular functions later on, can have a unique signature. Okay, so here is a syntax for a class, a constructor. So you have the accessor again, either public, private, right? Again, usually it's always public to create objects. Then followed by the class name. Okay, exactly the same name as your class. If you call it, uppercase apple, then it better be uppercase apple. It cannot be lowercase apple and so on. Okay, it has to exactly same name, same case, have to match character for character, and then and followed by a pair of parentheses, and then the parameters are optional. So here's an example of an employee class. There's a class name called employee, and then a constructor called public employee, and followed by a parentheses for a function. And I kind of put here together here because there's no data in there. It's empty. Okay, so so by default, if you don't supply a constructor, Java will create one for you automatically by default. Okay, because again, you cannot have a class without a constructor. Okay, so if you do have it, then this is how you would form one. And notice I did not put any data type in here. It does look like a function, but it's no data type because it is a constructor. Okay, it constructs something out of it because how can you tell? How can I cut? How if you put a data there? I mean, how do you distinguish between a object of certain data type? You can't, right? So this is by default the general constructor that's probably created by Java every time we run a program if you don't have a constructor. And then below here I have three different constructors. This will be your custom constructors. That means that you'll be writing them yourself, you create them yourself, you provide the constructors. If you don't, then again, Java will create one for you. So we have three different types here. The first one is it takes no parameter, as you can see. Inside that constructor, I update this emp num value to 12. I set that to 12. Okay. Assuming that these are example exists within the class up here. So this is emp num. Notice this has no value. The age limit is set to 25. These are initialization. Okay. So when I create a new employee, then age limit will be 25. Emp num will be set to 12 by default. Okay, that's one way how you can create a new object out of that. The next constructor takes one parameter, int a. Notice again it's the same name. Okay, so typically in a function or in any function you cannot have the same function name. Okay, you can try to do that and it will tell you that you already have a duplicate name. Just like if you cannot have a duplicate variable names in your code, right? You cannot use the same one. But constructor and methods you can, and the reason why is because, again, back to this term I call it the signature. Okay, signature means the parameters are different. So this one has no parameter. This one has one of type integer. This one has two, both integers. So therefore, these three are completely different they have different signatures. So therefore, it's legal in Java to create multiple constructors of the same name, even though they have the same name, but they have different signature. Okay? And this is very common in all object-oriented programming languages. When we say different signatures, different parameter type. Not just the quantity you have, the quantity and the data type as well. Okay, so if I create another one here, if you say quantity, well, this one has no parameter, this one has 1, this one has 2, so they're different. Yeah, what if I have something like this? And this is not int, but now is a string. And so maybe this could be like name A. Okay, so this has one parameter, but they're different type, so therefore they're different signatures. Okay, so so therefore it's legal. But if I have like int, C, then this will not work because I have this one here has an integer type, and this already has integer type, and they're only one parameter, and they'll be confused. So the program does not know which one to use in this case. So you cannot have the same data type with the same amount of parameter here, because this can be changed, right? This could be anything. It could be this could be X, Y, Z. Doesn't matter. It doesn't really, the program doesn't really care. Okay, so that's these are examples of constructors having different signatures. And I'll tell you why they're important. Why would you do that? Why do you need it? Okay, so let's say I have this one here, the int A and int AB. Now when I have those three constructors, so when I create new objects, I can do it this way. I can create one, employee one, takes no parameter. So when it takes no parameter, it will accept the default values of those two variables, right? I have the int num and the so the num will be 12. It will call this constructor, and then the num will be 12, and then of course the age limit will be 25 still. So it will have those two properties set that way. And the second one, I added one parameter, number 90. So it's going to go into the code here, and it's going to find which one of these takes one parameter of type integer. So it's going to take this one, and then 90, so therefore the num will be assigned with the value of 90. Instead of 12, it will have 90. And then the static, or the value for the age limit will still be 25. Okay? And then the third one, I supplied two parameters. So the num will be 55, and then the age limit will be 24. So it will replace whatever it's in there already. And so this is why it's important and convenient, because you can create an object right away and initialize the values to those. Okay. What if, for example, if I set this to nothing, if I do that, right? If you don't supply a value, and then now when I create an object, yeah, num will have 12, but the age limit has nothing. So in this case, the employee one does not have an age limit. So therefore, how do you change that? Well, then you will have to do something like this. To change it, you can say emp1 dot age limit is equal to 21. Okay, you have to manually change it yourself, and that's why it takes another line of code to do it, whereas I can do it all in one shot. Okay, so that's the reason why you have multiple constructors to supply these different data types, so you can initialize the values right away in one line of code, whereas if I don't do that, I have to do it 2-3 different lines, right? So it takes three lines of code. And if you have another employee, you have 3 more lines. So if you have 1,000, you have 30,000 lines, right? Or 3,000 lines, 3 times more. Whereas if you do this way, then you just have one line of code. Okay, so any questions on this? I know it's still really vague right now, but eventually you will understand, and it will become clearer when we get to do some more of the coding in the book as well as in the class here. Okay, so this is as far as I want to get with this chapter, and we'll do some examples. So let me just get out of this and run my Eclipse. And if you want to follow along, that's fine too. We can do it together so you can kind of get a hang of how that works. And we have plenty of time. We have like about an hour and a half, so we can do it together, and so you can understand how that's done also. Okay, so if you want to load your IDE, and we will run this code together. I have a problem here. What happened? Okay. All right, I'm going to close this. So, are all of you guys using Eclipse, or are you using NetBeans, or using different IDE? Okay. Yeah, if you use different ones, that's fine. It doesn't really matter. But I'm using Eclipse, so if you have any questions on the different IDE, please let me know. I know some students probably want to use JGrasp, which is nice. JGrasp is nice. Only thing is that it doesn't give you any of the intelligence. It doesn't give you any of the clues, so you can't know all the keywords, and you have to look up in the book and so on. So that's just the way we used to learn, and some people still do it that way. But for me, I just wanted something like right there available, like Google search, right? I don't have time to go Google search for it. Come on, just give it to me. And so there it is, right? So, but people learn differently, okay? Some people learn differently. They want to say, I want to know the words, the keywords myself, and I can do it better. That's fine, okay? All right, so in Eclipse, I just want to make sure you understand that in Eclipse here, you can have a lot of projects in here. You can do all your assignments for this class in a single workspace. Okay, I know you showed me you have a lot of the workspaces, but it's not really efficient because you have to keep loading every time. When you load a new workspace, Eclipse will reboot every time. And so just make sure you have a workspace here set up, and then just use that for the rest of this course. Okay? And then, so when you add a new project, it's going to add a new folder here, and you just keep going, and then, build your projects this way. So let's create a new project folder. I'll call it, maybe for me, just call it Unit 3. Okay. And the project name is 3, so the rest will be default. Just click Finish for that. I think we're good with this one. If you're using NetBeans, it should be very similar. I wish I could make this a little bit bigger, but can you all see? I know it's kind of tiny. Yeah, this part is not really important right now. What's important is on the right side here. Okay, let me do this.